everyone, Justin here. In our last lesson, we calculated the surface area of prisms. This meant adding together the areas of two bases and lots of rectangles. Today, we're calculating the surface area of pyramids. How's the surface area of a pyramid different from that of a prism? Well, I definitely see more triangular faces here, which is perfect because we know how to calculate the area of triangles. I bet we can calculate the surface area of pyramids too. Get your guided notes ready, and let's get into it. To calculate the surface area of a pyramid, we need to understand its dimensions so we can calculate the face's areas. The base of this pyramid is a square. So what do we need to know in order to calculate its area? Yeah, we need to know the dimension of one of its sides, like this. Then all the other sides of the square will be the same length, so these edges of the pyramid are also 5 units. Multiplying two sides will help us get the area of this square, but what about the triangular faces? What dimensions do we need in order to calculate the area of each triangular face? We'll need to know two dimensions, one of which is the length of each triangle's base. What base length do these triangles all have? Yeah, that same 5 units from before. What else do we need to know in order to calculate the area of a triangle? We need to know the triangle's height. Since these 4 triangles all use the same 5 units as their base length, they'll be identical and all have the same height too. And their height is this distance here. We can draw this distance on any of the triangular faces, like this triangular face along the left side, this one along the back, or this other triangular face here. This distance has a special name on a pyramid. It's called the slant height. The slant height is the distance from the edge of the base to the opposite vertex. It also forms a right angle with the edge of the base. The slant height of this pyramid is 8.1 units, which will be used as the height of each triangular face. All right, I think we're ready to start calculating the surface area of pyramids. We just need to remember to calculate the area of every face and then add them all together. Let's give it a try. Go ahead and do that for this pyramid. Pause the video and calculate the surface area of this square pyramid now. The base is a 5 unit by 5 unit square, so its surface area is 25 square units, which we can abbreviate using U as units. Any of the triangular faces have an area of 1/2 times a base of 5 units and a height of 8.1 units, which is 20.25 square units. That means we could just calculate the area of one triangle and reuse it 4 times. All right, now what should we do to get the surface area of this pyramid? Yep, we can add all these areas together. 25 plus 20.25 4 times, or 20.25 times 4, gives us 106 square units. Great work here. But what if the base of the pyramid is a rectangle instead? How does that affect the triangular faces? Since the sides of the rectangle aren't all the same, the triangular faces won't all be identical anymore. Only the pairs across from each other will match. That means these two have the same area as each other, and these two share the same area. Here are the dimensions for this rectangular pyramid. Notice that we have 2 different edge dimensions on this rectangular base, and because of that, we also have 2 different slant heights. Why do you think that is? Yeah, the pairs of triangular faces have different dimensions, so this 8.5 units will be useful when calculating the areas of these triangles that use the 5 units as the length of their base, and the 8.1 will be used to calculate the area of these two triangles that use 7.2 as the length of their base. Go ahead and take it from here. Pause the video so you can calculate the surface area of this rectangular pyramid. The rectangular base has an area of 36 square units. These triangular faces each have an area of 21.25 square units. And these triangular faces have an area of 29.16 square units. Now, we could just combine all these areas together, which gives us a total surface area of 136.82 square units. Nice work so far. I've got one more pyramid for us to work through. This one has an equilateral triangle as its base. Although it might not look like it from this angle, equilateral means the triangle sides are all the same length. If these three edges of the pyramid are all the same length, what does that tell us about the other triangular faces that aren't the base? Just like the square pyramid from our first example, this pyramid has a base where the edges are all the same length. When that's the case, all these non-base faces will be identical. They'll use the same 5 units as the dimension of their base, and will also use this same slant height as their height. That means this slant height of 6 units is also the slant height here and here. Okay, let's see how we can use the information we have so far. We need to calculate the surface area of this pyramid knowing it has an equilateral triangle as its base. To get started, go ahead and calculate the area of one of these non-base faces. Don't worry about the base for now. We'll come back to that in a minute. Any of these non-base faces has dimensions of 5 units and 6 units, giving them an area of 15 square units. And for the equilateral triangle base, we have dimensions of 5 units and... Wait, what's the height of this triangle? Ah, there it is, 4.3 units. Using these in the area formula gives us a base area of 10.75 square units. Combining all these areas together gets us 55.75 square units as the total surface area. Great job! Now you know how to calculate the surface area of pyramids. We also practiced reusing dimensions and areas for faces that are the same. Don't forget to complete this lesson's checklist, and I'll see you next time.